Welcome to the deep dive. Today we're jumping into something really core to making blockchains, well, useful in the real world. It's this challenge: how do you get reliable, real-world information onto a secure, isolated blockchain? People call it the blockchain oracle problem. And it's fundamental for smart contracts, everything from finance to, insurance, gaming. We're going to explore Chainlink, which is probably the biggest name tackling this. We've got white papers, industry reports, even some social media takes lined up.
Yeah, it's fascinating because, most people don't even think about this limitation until they hit it. Blockchains are powerful but isolated. Chainlink is essentially a decentralized network of oracles. Think of it as the bridge. Our goal today is really just to cut through the text geek and show you why this bridge matters. And not just for crypto folks, but potentially for, loads of industries looking at smart contracts.
Okay, let's unpack that core problem then. You've got smart contracts, these amazing self-executing agreements on the blockchain, super secure, tamper-proof. Their strength is that they're locked down, deterministic. But that's also the problem, right? How does that locked-down contract know, say, the price of oil right now? Or if the flight it's insuring was actually delayed, it can't just Google it.
Exactly. That's the oracle problem in a nutshell. Without a secure way to get that external data in, smart contracts are stuck dealing only with data already on their own chain. Think about it: crop insurance needing rainfall data, financial derivatives needing live market feeds, prediction markets needing election results. None of that originates on the blockchain. And if you just feed it in from one central source, you've defeated the whole purpose of decentralization.
You've created a single point of failure.
Precisely. So an oracle isn't just one thing, it's the entity, or really the network, that bridges that gap securely. Chainlink came about specifically for this. Back in 2017, Sergey Nazarov, Steve Ellis, Ari Jules at Cornell, they put out their white paper then, and the network really launched in 2019. They pioneered this idea of hybrid smart contracts.
Hybrid,
meaning they combine the secure on-chain code, the smart contract logic, with essential off-chain information and even computation. It's that blend that makes them powerful for real-world use.
Okay, so we get why we need this bridge. But how does Chainlink actually build it? How does it move that vital real-world info onto the chain without, compromising the security or the decentralization? Because like you said, if the bridge itself is weak or centralized, the whole thing falls apart.
Right, and that's the crux of it. Chainlink's answer is its structure as a decentralized oracle network, a DON. Imagine it not as one bridge, but a whole network of independent bridge operators, or nodes. These nodes operate both on-chain and off-chain.
Okay, break that down. What happens on-chain?
So, on the blockchain itself, Chainlink runs smart contracts. Think of these as the administrative layer. There are contracts for managing node reputations, who's reliable. There are contracts for matching data requests with available nodes, the order matching. And importantly, there are aggregating contracts that take all the answers from different nodes, filter out any weird outliers, and arrive at a single trusted data point. It's like decentralized quality control.
Got it. So the on-chain part is like the referee and scorekeeper. What about off-chain? Where does the actual data fetching happen?
Now, that's the off-chain component's job. Each node runs software, Chainlink Core, which listens for requests from the blockchain contracts and knows how to talk back to the blockchain. But the really flexible part is the external adapters. These are basically plugins. They let node operators connect to almost any external data source, premium financial data APIs, weather stations, IoT sensors, you name it. Need data from a specific private database, you can build an adapter for it. That's how it connects to the entire rest of the world's data.
Okay, that modularity makes sense. But connecting to anything also sounds risky. How do you trust the data coming through those adapters and nodes, especially if it's coming from outside the blockchain's secure walls? That seems like the critical trust point.
Absolutely crucial. And Chainlink tackles this with several layers of security. First, as we touched on, distribution. It's not just one node fetching data from one source. A request typically goes out to multiple independent nodes, and those nodes might themselves query multiple independent data sources. Then the results are aggregated on-chain. So if one source is wrong or one node is flaky or malicious, its answer gets drowned out by the consensus.
Safety in numbers, essentially.
Pretty much. Second, there's a clever mechanism called the commit-reveal scheme. This stops nodes from being lazy or cheap. See, getting some data might be expensive. You don't want one node paying for the data feed and others just copying its answer. So first, all participating nodes submit an encrypted commitment basically saying, I have an answer, here's proof. Well, only when enough commitments are in do they all reveal their actual data simultaneously. Keeps everyone honest.
Ah, okay, that's smart. Prevents freeloading.
Exactly. And looking ahead, Chainlink is also heavily involved in integrating trusted hardware. Think secure enclaves like Intel SGX. These are like tamper-proof black boxes inside the computer's processor. Systems like Town Crier, which came out of Cornell too, use this to prove data was sourced correctly and wasn't messed with, even by the node operator themselves. It adds another strong layer of integrity, especially for sensitive data.
Right, layers upon layers of security. But running these nodes, getting the data, maintaining uptime that costs money and effort. What's the incentive? How are node operators paid?
That brings us to the LINK token. It's the network's native cryptocurrency, and it's central to the incentive system. Node operators are paid in LINK by users requesting data. Fees are set based on demand and the complexity of the job. But it's not just payment. Operators also have to stake LINK as collateral. If they provide bad data or have poor uptime, some of their staked LINK can be taken away as a penalty. So there's a real financial incentive to be reliable and honest.
Skin in the game.
Precisely. And LINK, being an ERC20 token, just means it works seamlessly within the Ethereum ecosystem. Easy to store, easy to transfer.
Okay, so staking LINK is key for node operators. But you mentioned earlier that the community can also get involved in securing the network. How does that work? Tell me more about Chainlink staking.
Yeah, this is a really important part of the crypto economic security model. It's not just nodes staking. By allowing the broader community to stake LINK, the network increases the total amount of value securing Oracle services. It basically raises the cost of trying to corrupt the network. The V.2 upgrade back in November 2023 was a big step here.
What changed the V0.2?
It really opened things up. The total pool size for staking was increased significantly to 45 million LINK, and it made it much more accessible. Community members could stake with as little as 1 LINK, up to a cap of 15,000 LINK per address. Node operators have their own higher tiers, from 1,000 up to 75,000 LINK. It allows for much broader participation.
45 million LINK. That's a lot of value securing the network. Yeah. So what are the actual rewards for staking, and are there catches? What about the risks?
The rewards are designed to be attractive. It's a dynamic rate. It adjusts based on how full the staking pool is. When the pool is full, community stakers get a baseline floor reward of 4.32% annualized paid and linked. If it's less full, the rate can actually be higher to incentivize more staking. Now, regarding catches, there's an unbonding process if you want your LINK back. It's not instant. There's a 28-day cooldown period, then a 7-day window to claim your tokens. This prevents sudden shocks to the network's security. And if you unstake early during certain periods, like the initial 90-day ramp-up for locked rewards, you might forfeit those accrued rewards. It encourages long-term commitment.
Okay, so there's a time commitment. What about the slashing risk? If a node operator messes up and gets slashed, do community stakers lose LINK too?
That's a key point for community members. In V0.2, community stakers are not subject to slashing. The node operators bear that direct financial risk for their own performance failures. For example, if a node providing the Ethos price feed is down for more than 3 hours, it might get slashed, say, 700 LINK from its stake. But the community stake isn't touched by that specific node's failure.
Okay, so the community provides broader security capital, but isn't penalized for individual node errors. That's interesting. Do they have any active role then?
Yes, a very important one. Community stakers can act as monitors. They can raise alerts if they detect an Oracle service isn't meeting its performance standards. And if the alert is valid, say, proving that a data feed really was down for too long, the alerter gets rewarded, potentially quite significantly, like 7,000 LEAing for a successful alert. It turns the community into a decentralized watchdog force.
Wow, so you get rewarded for helping maintain network integrity. That's clever.
Exactly. And on top of the base staking rewards, there's the Chainlink rewards program. This is where other projects building with Chainlink contribute their own native tokens to reward LINK stakers. For instance, Space and Time, a Web3 data warehouse project, committed 100 million of their SXT tokens for distribution to eligible LINK stakers starting around May 2025. It creates this really nice flywheel effect, aligning incentives across the whole ecosystem.
That's a powerful ecosystem play. Okay, let's pivot a bit. We've talked a lot about the tech, the security, the economics, but where does the rubber meet the road? What does all this actually enable? Where are we seeing Chainlink making a real difference today?
Right, the impact. Well, DeFi, decentralized finance, is probably the most obvious and massive use case so far. Honestly, much of DeFi simply wouldn't exist or wouldn't be trustworthy without Chainlink price feeds. Protocols like OV for lending, Synthetics for synthetic assets, DYDX for perpetuals, they rely heavily on Chainlink for accurate, real-time, tamper-proof market data.
Can you give a specific example?
Sure. Think about something like the Chainlink DeFi yield, CDY index. It tracks the lending yields you can get on major stablecoins like USDC, USDT, and also wrapped assets like WBTC and WETH. We saw data showing that between December 2023 and March 2024, the amount of wrapped Bitcoin that's Bitcoin usable on Ethereum in lending protocols grew from about 40,000 to 50,000 tokens. Chainlink feeds showed how that influx actually pushed down lending yields for stablecoins like USDC and USDT because there was suddenly more collateral chasing borrowers. It provides that crucial market transparency.
Interesting. And what about bridging to traditional finance? You mentioned Bitcoin earlier.
Yes, Bitcoin adoption by institutions is another key area. Chainlink Proof of Reserve, POR, is vital here. It provides on-chain verification that the reserves backing a tokenized asset like wrapped Bitcoin actually exist. WBTC has used Chainlink POR since 2021. This became even more relevant with the launch of the spot Bitcoin ETFs in the US in January 2024. For example, the ARKB ETF uses Chainlink POR, pulling data from Coinbase Prime to let anyone publicly verify the Bitcoin backing their shares. That builds enormous trust.
Transparency for traditional players entering the space, that's huge. And what about that cutting edge stuff, the super high frequency data you mentioned?
Ah, yes, the Chainlink data streams on Psy Network. That integration just happened September 10th, 2025. It's a really big deal. Psy Network is positioning itself for high-frequency trading, and Chainlink is now providing sub-second market data feeds there. But what's truly groundbreaking is that they're also bringing official U.S. economic data on-chain via these streams, things like real GDP, the PCE price index, straight from the Bureau of Economic Analysis.
Wait, verified government stats updated almost instantly on a blockchain.
Exactly. Verifiable, high-frequency, low-latency data, including things like liquidity-weighted bid-ask spreads from exchanges. The implication is massive. It enables institutional-grade applications. Think real-time trading of tokenized stocks, bonds, complex derivatives, all settled on-chain with data that meets institutional standards. It's a major step towards merging TradFi and blockchain infrastructure.
That really does blur the lines.
Yeah.
Okay, besides finance, which is clearly huge, what other areas are seeing traction?
Oh, it's spreading out. Insurance is a big one. Parametric insurance, specifically. Instead of lengthy claims processes, a smart contract can automatically pay out based on verifiable data from an oracle. Like, if a Chainlink weather feed reports hail of a certain size in your area, your hail damage policy pays out instantly. Gaming is another. Chainlink VRF, verifiable random function, is used everywhere. It provides provably fair randomness for things like loot box drops in games, NFT minting characteristics, or selecting winners in a lottery. Players can verify the randomness wasn't manipulated.
Removes the house always wins.
Precisely. And then you have use cases emerging in supply chain tracking, verifying digital identity, targeted advertising based on verifiable credentials, decentralized governance decisions. It's really broad. The scale is impressive now. As of May 2025, something like over 2,300 projects were using Chainlink. It's secured tens of trillions in transaction value on-chain. And it's trusted by huge names exploring blockchain, like Swift, Euroclear, MasterCard, Fidelity. The list keeps growing.
That scale and list of partners is definitely telling. But as with any successful tech, competition emerges. Chainlink isn't the only Oracle solution out there, is it? What are some alternatives, and why might someone choose a different path?
That's a fair point, and a healthy ecosystem needs alternatives. Chainlink is dominant, but others are tackling the Oracle problem with different approaches or focuses. Developers might look elsewhere for reasons like potentially lower costs for simpler data needs, maybe specific cross-chain requirements, higher perceived scalability for certain niches, or just a different philosophy on decentralization or security.
So who are some of the other players?
Well, you've got Band Protocol, for instance. It's built using the Cosmos SDK, so it puts a big emphasis on cross-chain compatibility and enabling developers to create custom Oracle scripts easily. Then there's API 3. Their approach is quite different. They focus on enabling direct connections between decentralized applications and existing web APIs, operated by the API providers themselves. The idea is to cut out middlemen oracles entirely for certain use cases.
Interesting, a more direct model.
There's Provable, formerly Oraclize, one of the older players, often noted for its use of authenticity proofs, sometimes involving those trusted hardware elements we discussed. Teller is another prominent one, known for its Oracle system that relies heavily on staking, and a dispute mechanism where data reporters compete to provide information and token holders vote on validity. Very community-driven security. DIA, which stands for Decentralized Information Asset, focuses specifically on sourcing and validating financial data, often directly from exchanges and on-chain sources. And you also have systems built for specific ecosystems, like MakerDAO's Oracle system, which is highly tailored and hardened specifically for maintaining the stability of their DAI stablecoin.
So quite a diverse landscape, each with maybe a slightly different trade-off or focus.
Exactly. There's no single best oracle for every situation. It really comes down to the specific needs of the application cost sensitivity, the type and frequency of data required, the desired security model, cross-chain needs, and so on. It's good that developers have choices.
Absolutely. Wow, okay, we've covered a huge amount of ground. From the fundamental why of the Oracle problem to the nuts and bolts of Chainlink's decentralized networks, the crucial role of LINK staking and security, all the way to its massive impact in DeFi, its growing role with institutions, and these diverse uses in gaming, insurance, and beyond. And acknowledging the alternatives, too, really underscores Chainlink's position as this vital, trusted bridge making smart contracts truly powerful for the real world.
It really does. And maybe a final thought for you, the listener, to chew on, building on all this. As we see more and more real-world information, financial data, economic stats, maybe even aspects of personal identity becoming represented on-chain, secured and verified by systems like Chainlink, ask yourself, how might having this data in a verifiable, immutable, transparent form fundamentally change how we interact with businesses, with governments, with each other? How does it reshape trust in a digital age? This convergence of the physical and digital, the traditional and the decentralized, it's happening now, and thinking about its deeper implications, maybe for your own work or interests, is definitely worthwhile.